Welcome to CCCC Library's segment on searching for sources in popular science. Today we're going to talk about scholarly versus popular articles, how to evaluate articles, and how to spot pseudoscience. Let's dive in. What is popular science? Popular science is a genre of writing that aims to make scientific concepts accessible to the general public. Unlike academic papers, which are written by and for experts, popular science articles are usually written by journalists or scientists who aim to explain complex topics in an understandable way to us, the common person. They often appear in magazines, blogs, and websites like Scientific American, Popular Science, and National Geographic. So let's learn some more about the differences between scholarly and popular articles. Scholarly articles are typically peer-reviewed, meaning they've been evaluated by other experts in the field before publication. These are usually published in academic journals like Science, the New England Journal of Medicine, or Nature. At first, these might look very similar to popular magazines, but academic journals contain in-depth analysis usually presented in the IMRAD format. IMRAD stands for Introduction, Method, Results, and Discussion. Scholarly articles typically follow this format and include original data and a list of references. Popular articles, on the other hand, are not usually peer-reviewed. They focus on summarizing scientific findings in a more digestible format, often without the technical jargon that scholarly articles use. While they are valuable for general understanding, they may not provide the detailed evidence and rigorous analysis found in scholarly articles. So how do we evaluate popular science articles? When reading popular science articles, it's important to consider a few key factors. Source credibility. Check the reputation of the publication and the qualifications of the author. For instance, is the article from a reputable magazine or website? Or does the author have a background in science or science journalism? Citations and references. Good popular science articles will often link to or mention the original research or scholarly articles they are based on. This transparency helps you trace the information back to its source. Clarity and accuracy. Watch out for sensationalism. Science is complex, and while good writing can make it accessible, it shouldn't distort the facts or overstate the implications of a study. Bias. Be aware of potential biases in the presentation of information. Biases can come from the author's personal beliefs, the publication's editorial stance, or commercial interests. Look for balanced reporting that considers multiple perspectives and doesn't selectively present data to support a particular viewpoint. Spotting pseudoscience. Pseudoscience is information that masquerades as scientific, but it lacks credible evidence and rigorous methodology. Examples of pseudoscience include flat earth theory, crystal power, crop circles, and astrology. Pseudoscience often uses scientific-sounding terms and concepts to appear legitimate, but it doesn't follow the scientific method or peer review process. Take the claim of Bigfoot's existence. Despite numerous alleged sightings and anecdotal reports, there's no credible scientific evidence to support the existence of such a creature. Most of the so-called evidence, such as blurry photos and footprints, lack verifiable data and rigorous scientific investigation. Many Bigfoot claims rely on personal testimony rather than empirical evidence, and they often ignore the lack of biological or ecological feasibility for such a creature to exist undetected. Some red flags of pseudoscience include lack of peer review. Genuine scientific findings are usually published in peer-reviewed journals. Pseudoscience often bypasses this scrutiny and is promoted through non-scientific channels. Over-reliance on testimonials. Stories and testimonials are often used in place of solid evidence. While personal experiences can be compelling, they don't substitute for controlled, repeatable scientific studies. Exaggerated claims. Pseudoscience frequently promises quick, dramatic results or cures. Be wary of terms like miracle, breakthrough, or secret that appeal to the emotions rather than reason. Scientific jargon. Using complex terminology without clear explanation can be a tactic to appear credible. Genuine science communication aims to explain concepts in understandable terms, not obscure them. And financial or ideological motives. Sometimes pseudoscience is promoted for financial gain or ideological reasons. Be cautious if the primary promoters have something to gain, whether it's money, influence, or support for a particular worldview. In summary, while popular science articles are great for broadening your knowledge and understanding of scientific topics, it's essential to evaluate them critically. Look for credible sources, transparency in references, clear and accurate reporting, and a balanced presentation of information. And always be on the lookout for pseudoscience, which can mislead and misinform. Thank you for watching, and remember, a critical eye is your best tool in navigating the world of science communication. Stay curious, stay informed, and see you next time.